topic on the whole of A-level syllabus, on the whole of A-level computing. There we go. So it's all about storing data. The database is just somewhere to put your data, as we agreed earlier. So where else could you store your data? If it's just I don't know, just, like right now, you're writing data. I'm telling you like mark scheme, and you're making your own little data stores. You could store your data in a list. If you just write your data on a post-it or on some notes, or you just make a text file, a .txt file, and just write all your data in a .txt file, store it in a list. That has a special name. It's called a flat file. This is a flat file database. It's still a store of data. And when we did some Java programming last year, you learned how to, you've got your Java programs, you can store stuff in a .bin file, or you can store stuff in a text file. Last year you learned how to store stuff in a text file, which is handy because you can, load and save stuff. So some of you, obviously last year, you learned how to write programs in Java to store stuff in text files. Some of you are now writing programs to store stuff in databases. No? Maybe? Possibly? Your projects are in process, at least, in progress. Say again?
I don't need to use databases yet.
No, not everyone does need to use them. So there's a number of problems with flat file databases. One of them is that data can be duplicated and inconsistent, and therefore inconsistent. So if we look at the list here, if the college were to store all its data like this in a simple list, what happens if there's a room change for physics? If there's like a physics, if the college stores all its data in a text file, and there's a room change, what happens with a room change for physics? What do you have to do? Done?
Change all of the data so that make sure it matches, and it'll be like really hard to find.
Yes, you have to first find where that name is written, where DO5 is written, where physics is written, and then change DO5 to wherever the new room is several times, as many times as in the database. So you've got to keep looking for it. And if you miss one, like, I don't know, if you're going through your database and you change it for under Helen Jones, but you don't change it under Sally Struthers, then, well, Sally Struthers goes one place and Helen goes to another place. So in a flat file database, your data is duplicated, inevitably. If you're storing large amounts of data, you're going to have to duplicate your data at some point. And that can lead to it being inconsistent. This is mark scheme, by the way. So this is a flat file database. Data can be duplicated, and because it's duplicated, it can be inconsistent. Aside from the fact, you're wasting storage space. You could also write that down. You are wasting storage space. You've had to write the same thing down in 2 different places. And as your database grows, that can become the large amount of wasted space. Slows things down, slows your searches down. So flat files are good because they're simple, but they have this big problem that data can be duplicated and therefore inconsistent. The other problem with files, you may not have come across this much yet, but if you do much work over a network and you have to share files with other people, only one person can open a text file at once. If someone else tries to open it, they usually have to make a copy of it and then or open it read-only. Because if someone tries to write to this file whilst you're also writing to the file, who wins? If you try and, I don't know, change that to change the room to DO4, and I try to change it to DO6, who wins? 2 people try and write to the same file at once, it doesn't work. So you can only have one editor at a time in a flat file database. The other thing is that if you'd got quite far last year when we were storing writing our Java programs to store our data in a text file, you'll have known that if you want to sort something, if you want to find something in your text file, you have to write that yourself. or if you want to sort it or add it or remove anything, you have to write that code yourself. Or think of another way, if you're using your laptop to take notes. Okay, so you might be able to do Control F, because the people who wrote the word processor might put a search program in it, but they probably won't have written sort or add or remove. You're going to have to do that manually. Whereas in a spreadsheet, what's quite handy is the ability to be able to sort things by different columns. And in a database, that's even better. So, 3 bits of mark scheme. This is a flat file database, the most simple, basic kind of database you get. And it's fine because it's simple, and if it's small, then that's okay. But when your database grows and more people want access to it, it causes problems because your data ends up being duplicated and inconsistent. You can only have one person editing it at a time, and if you want to you have to write your own code to add things, to sort things, to search, remove. You have to write your own code to do that. If you've got a program which is a website or something, and you're storing everything in a text file, or your Java program. There's also no security. Either you can open the text file, or you can't. Because everything's in the text file, one person can literally see everything that's in that file. If you can see the file, you can see everything in the file. So in this example, maybe it's not so bad, where this is just a simple timetable. But if you imagine the college's full database, we store quite a lot of sensitive data about students. If you're having problems at home, or if you have some disability, or I don't know, if you've got a criminal record or something, all that information would have to be stored in this same program. So when you wanted to check your timetable, you could also see everyone else's timetable, and whether they've got a criminal record, and if they're having issues at home, and all the other comments we stored about them, and all their grades, which we wouldn't really want. Sometimes it's good to just let people see a little bit of the database, not the whole thing. So normally you'd think of those as text files. A flat file is basically like a text file, simple text file database, or a simple text file. When you think of a database, most of the time what you're actually thinking about is what's called a relational database. So the traditional example, like a database, when people talk of databases, what they really mean is like a relational database. They're not talking about a flat file database. Even though, you can store your data in a text file if you want, that technically makes it a database. Still, it's not a relational database. Relational databases, the way they work is rather than having one giant list, you have lots of little lists. This isn't mark scheme, this is just me explaining what a database is. So, in a relational database, in a proper database, you have lots of little lists with links between them. Guess what those links are called? And you can have many connections at once, because different people can be connecting to different lists. So I want to edit your timetable, someone else wants to do their register. That works, because they're two separate lists. And most of the time, you just want to view stuff. You don't necessarily want to have to write to it. And even if you do, you're just adding like a row at the bottom. So you can mark the bottom bit, and other people can be editing at the top. There may still be occasions where you've got two people trying to change the same piece of data at once, in which case the database does something called record locking, which we'll talk about again in a minute. But you can have many connections at once. Many people can be editing all these different lists at once, and that works fine. So as a crude example, similar to what we had before, we have two separate lists. We have one list for the students. So we've got one list that stores all the students' information. This is quite a small example, but you can imagine we could store quite a bit of student data there, including what subjects they're studying. And then we have a separate list to store all the details about the subjects. Again, there's not much information there, but we could add things like lecturer and how big the room is, how many computers in the room, all the details, or what the exam board is. We could add lots more details about that subject. So we've got two separate lists, one for students, one for the subjects, and we create links between them. So notice that now we only have the details of this particular subject in here once. We have the time, we have the room, and that's all we need. So if there's a room change, we only need to change it in one place. And if Helen wants to see where she's supposed to be taking physics, so Helen can log in, and it's a bit like clicking on a link, and that takes her to this data here. It's a bit like, we have web pages, similar kind of thing. So Helen can click on physics, and that'll take her through to all the physics information. Similarly, Sally Struthers will click on physics, and that'll take her through to the physics information. Yeah. That's it. That's basically all. That's how all our databases work. That's really all you need to understand, and the rest is just detail. But this is basically how databases work. This is how relational databases work. This is all it's about as hard as it gets in terms of actually understanding how databases work. Though there's more to come, I'm sure. The rest is lots of words. There's lots of special words to describe how databases work. So as we can see, in a relational database, there's no duplication, there's no inconsistency. It's easy to add new data, and it's easy to control your data. It's easy to change it and update it, because you can find it easily, and once you found it, you only have to change one of them, rather than trying to find all the places where you've written this thing. So yeah, the stuff in black is the mark scheme. So if you get a question that says, what's the advantage of a relational database over a flat file? That's your answer. You could also say something about security and all the disadvantages of a flat file or advantages of a relational database. So a relational database is a concept, it's a theory. It's this ephemeral idea. In order to implement these ideas, we need what we call a database management system. And this is where you start giving it a name. So, like Oracle is a database management system, MySQL is a database management system, SQL Server is a database management system, even Access counts as a database management system. And the database management system controls everything. Controls access to the data, controls security, controls where it's stored on the disk, controls what's allowed. Sometimes adding stuff to a database, databases can be very specific about the data that they will and will not let you store. When you're trying to add something to a database, think about it. When you're filling in an online form, and you don't fill in one of the fields, it won't let you continue. It'll go, no, I'm not going to do anything else until you fill in this box here. Or if I ask you for your phone number and you type 5, it goes, no, that's not your phone number. Put in a proper phone number. Exactly. They are quite specific about what they will let you store, what they will and will not let you store. They can be very picky. And if you can just imagine for a moment, that's part of the joy, I guess, of being a database administrator, of trying to figure out, why won't you store this data? Sometimes it's hard enough trying to fill in why you click next and it won't let you. It says a required field has not been entered. Which one? Where? Give me a clue. Often it will give you a clue, but if you imagine trying to write the code to check that everything is going in the right place, and then highlighting where it isn't, and trying to explain why. That's part of the joy of being a database administrator and database designer. Engineer is a good term. So the database management system controls everything. Controls the organization of the data, the storage and the retrieval of the data. Think about that for a moment. That's quite nice. As a programmer, it's nice to be able to say, store this there. I'm not really bothered about how. I'm just writing a pretty interface. The database takes care of exactly where it's being stored, and how it's organized, how it's sorted, and things. Similarly, you can get it back quite easily. If you're storing everything in a text file, you have to say, search through the text file until you find the end, and then put it at the end, and then later on when you want to try and find it. You have to search through everything one at a time, looking for the specific thing you're looking for. Whereas the database management system, you just say, here's some data, store it somewhere. Not really bothered about where. And then when time comes to bring it back, you just say, find me everything related to this. And it will go off and find it for you. You don't have to explain how. You don't have to code it for yourself. Also takes care of security. Most databases come with security sort of built in. As well as being able to store students and subjects, I mean, one of the things it will store about the students is your student ID, and the other thing it will store about you is your password. So it has, the database will have security built into it. Yeah, so it'll have your username, will have your password, and also have your access rights, perhaps. So some people can see more than others. It will say, this person, that's their username and password, and they can see these bits of the database. So you'll have all that in one of your lists. It also manages the integrity of the data. It makes sure that you're not storing the wrong data in there. If you try and enter a telephone number of 5, it'll go, no, that's not true. That's not correct. It forces you to enter correct data. And basically, it takes inputs and gives outputs, like any other computer system. Input, output, process, storage. Remember that? That's basically, the database does the whole thing. Takes your inputs, obviously gives outputs. In between, it'll do some processing, so it'll give it an input saying, I want to find all the data to do with this. So it'll take that input, it'll process it, it'll look through its storage, find the result, and then give an output. Yeah, and there's some examples. We've got Oracle, MySQL, SQL Server, Access. Those are the big ones, I suppose. In order of importance, I would guess, or certainly in terms of order of amount of money you can make from mastering them. Oracle is based on SQL these days, but actually it always was. But it is a very powerful database management system. Oracle have spent lots of money developing it, and it's like if you're Mercedes-Benz or if you're like a massive international organization and you want a database to store your important information, the information that you need in order for your organization to survive, generally you choose an Oracle database. There's something called SAP, which is like the full suite, like I was explaining earlier, the Mercedes-Benz example. The data will probably still be stored in an Oracle database, but all the updating and reporting and stuff might be handled by an ERP system such as SAP. Don't worry about that. Oracle, if you understand Oracle, if you're Oracle certified, Oracle do have a certification program as well. If you understand how to administrate an Oracle database system, then your starting salary will be like 40 grand. And you're rising up to like 80 grand. And because like companies that have Oracle servers, Oracle databases spend a lot of money on them. And when they go wrong, or if something bad happens and they need someone to fix it, then you can turn up, make that crucially important change, collect your 6-figure salary, and then go back to your yacht in the Bahamas. So Oracle, well worth mastering and learning and spending some time getting to grips with. If you can become fully Oracle certified, then the world will be your oyster. And there's a lot of demand. There's a lot of demand for Oracle engineers. Oracle got so big and made so much money that they then went and bought Sun Microsystems. Sun Microsystems, Sun stands for Stanford University Network, I think, or Stanford User Network. They invented lots of things, including Java and MySQL. So weirdly, Oracle now owns MySQL, which is the open source alternative. Most of the world's database servers use MySQL, mainly because websites use it a lot. There's like 80% of the world's web servers use Linux, Apache web server, and a MySQL database with PHP modules built into Apache. And so MySQL is very, very popular. It's very, very common. Basically because it's open source, so it's kind of free, but it's also really good. It's written by the same people who write Oracle stuff, or at least it's owned by the same company. And it is very good, has a very good reputation, and it's what I spend most of my time. I spend quite a lot of time with SQL, with MySQL. SQL Server comes with Windows Server. It's written by Microsoft. It's better than Access by a long shot. It's a lot like MySQL in many ways. There isn't actually that much difference between them. But it's slightly different. It's Microsoft. And usually, if you're using PHP, then you'll probably be using a MySQL server. If you're using ASP, you'll probably be using an SQL server. And lots of professional companies have written like entire products around SQL Server. Something called Sun Accounts, which is like this big financial package, which is one example, but it's just basically a pretty front end with an SQL Server on the back end. And if you're upgrading, migrating, if you're doing any sort of project management in the real world, you will probably come across SQL Server a fair bit. MySQL, because it works so well and it's set up on Linux, most of the time you will set it up, you install it, and you just leave it. You don't need to fiddle with it because it generally doesn't break very often. But Windows, you need to, they have their upgrade cycle. Your Windows server will need upgrading probably twice as often as your Linux server, and you'll be migrating Windows quite a lot, therefore. And Microsoft are always saying you need to install antivirus and you need to install many, many patches, so things will occasionally work and then occasionally stop working, and you need to figure out why, and other things will conflict with SQL Server because Microsoft Exchange, have you heard of Microsoft Exchange? Yes? No? Maybe? Anyone heard of Microsoft Exchange? It's the email program that sits on the back of Outlook. So Outlook is the pretty interface, is the window into the database that stores all your email and all your appointments and all your contacts and everything. That's all stored in a massive SQL database, believe it or not, managed by this system called Exchange, which allows you to connect Outlook to it. And Exchange also uses SQL Server. And if you have like an SQL server and Exchange on the same physical server, they compete for resources, and then depending on what patches you've got, different systems will be winning. And so one day you'll find that everything's working fine, and the next day you install a new patch or you upgrade Exchange, and Exchange gets a small performance boost, but your SQL server just grinds to a halt and you have to figure out why. Usually best to have your SQL server and Exchange on separate physical machines. That's just an anecdote. Access, like I've already suggested, is fine for fiddling around and getting a rough idea of what a relational database is, but to be honest, if you really want to learn how to build databases, the best thing is MySQL, because it's free and you can install it on any computer. It's a program called XAMPP. Have I mentioned this before? XAMPP is really good. We'll fiddle with it. I've got it installed upstairs. You can connect to it over the network, and I'll get you to run some SQL commands, build some databases, build some tables, and then try and put some security on them to stop each other from ruining each other's databases. Which you do actually have to do because you need to learn some commands for the exam. There's like snippets of SQL code and you have to interpret them. So it's not just for fun. So there's a bunch of new words for you. You ready to write these down? Examiners love words that sound complicated and you have to then describe them. So here's some of them. First one is entity. And then leave some space for describing what they are. In fact, what you might like to do is this is going to be on the screen for a while, so just let them wash over you for a moment. I'll explain what they are, and then you can draw some diagrams. Attributes is another word. Primary key, secondary key, and tuple. Great words. So this is one of the lists that we'd have in our database. I'm going to start calling them lists. I'm going to start calling them entities. You will also see them referred to as tables. SQL calls them tables. In exam land, they're called entities. So this whole thing is an entity. You can call it the student entity, or the student table. The list of all your students and all their details. This is the entity. So this is an entity. Each column is a set of attributes. So an entity will have many attributes. So it'll have the student number attribute, it'll have the first name attribute, the surname attribute, the address attribute, the phone number attribute, and the email attribute. Happy? Simples, really. So we have an entity. An entity will have attributes. One of those attributes is special. The student number in this case is the primary key. What makes... So you all have a student ID. Why? Why have you got a student ID? What's the student ID for? Why do we need it?
It's a unique attribute which is only unique to what it's something that's searchable. So, like, some attributes will be similar, but the primary key will be unique.
Absolutely. You're spot on. The key word there is unique. The primary key will uniquely identify a record in the database. So the primary key is a unique identifier. It uniquely identifies a record. So, for example, I don't know, 90213 is Emmett Brown, and that's his address, and that's his phone number, and that's his email. And 90213 uniquely identifies Emmett in this table here. There might be more Emmets in this table, so you can't use his first name. There might be more Browns in the table, so we can't really use his surname. In fact, if this is a student entity and we're talking about the college, you can't really use any of those because you might have, like, I don't know, brother and sister that live at the same address and therefore have the same phone number. Email is an increasingly useful unique identifier, and often you'll use this in other places, but not here. We still use student IDs for now. But yeah, increasingly you'll see email being used as a unique identifier because most people don't share an email address these days. They may have done once. Like, often you'll have maybe a family email address where it's just like, I don't know, the Smiths at AOL.co.uk.
I've never ever heard of a shared email.
Well, it has been a while. It's not very common these days. But it does occasionally happen. So, each of these is a record. You can also call them a tuple. So each row is a tuple. Each column is an attribute. The primary key is the attribute which will uniquely identify any tuple. A unique identifier is really all the examiners need. Surname is still quite useful though. I have no idea what your student numbers are. I'm sure I've seen them and read them at least once, but I haven't remembered them. If I'm honest, I struggle enough with your names after 2 years still. But I can at least now remember your names. So if I want to search for you, if I want to, I don't know, find out what your timetable is, or I don't know, if I want to write up a reference for you, I'm not going to find you by your student number. I'm going to type in your surname. I'm going to search for you by your surname. That's to be a common thing. I'm not going to search for you by your address or your phone number or your email address because I don't know what they are. But surname, logically as a human, you can think that most teachers are going to try and find you by either your first name or your surname. These are secondary keys. They're not unique, but we use them to search a lot. And I'll give you the exam definitions of these words now. So an entity is a thing about which you need to store data. That's what the examiners say. Technically, I don't think that's actually entirely correct because it's not really a thing. It's a collection of things about which you need to store data. So the student entity doesn't store information about one student. It stores about all the students. So technically, what would be more correct is a collection of things about which you need to store data. You might also like to write entity slash table. If you think of entities as tables, that's true. Entities are tables. SQL calls them tables, and the table is easier to visualize. For an exam land, an entity is a thing about which you need to store data. An attribute is a property of an entity. Attributes give you the properties of these entities. The primary key is unique identifier. Every entity should have a primary key. The other important thing about primary keys is that they are used to relate entities. Remember we saw before that we have our student list and we have our subject list. And in the student list we had the word physics, and then that linked to the primary key of the second list. Because physics was only in that list of subjects once. Maths was only in that list of subjects once. And so on. So in that case, the primary key was just the name of the subject. And the secondary key is indexed to allow for faster searching. Remember what an index is? Imagine that all the students are stored in alphabetical order by name. And what you can do is say all the A's start at this address, all the B's start at this address, all the C's start at this address, all the D's start at this address, and so on. So if you wanted to find, I don't know, Mills, then you'd look in the index, find the starting memory location for M, and then you'd skip straight to there, because it's faster. Remember what an index is? It's just a list. So in this case, the index would be a list of like letters and their memory addresses, and that will be the memory address of the starting memory address of all the names that begin with that letter. Yeah? That's it. There's a whole bunch of new words for you.
So you never actually talk about the tuple, really?
We do. No, not much, but yeah, the tuple's there. You can call it a row or a record as well. They're basically the same thing. Oh yeah, so I haven't seen a past paper question which said, define the term tuple. You could put a row, a record in the database which stores information about an entry in the database or something. But that hasn't been in the... I don't have the mark scheme for that because they never asked that question before. But they have often asked, define the term primary key, and define the term entity, and define the term secondary key. They asked those, so they've asked those several times. So, here's an example. We have well, actually, rather than me telling you, Mike, can you tell me, can you name an entity from this picture? Pitch, yes. Pitch is an entity. Good, well done. Curtis, can you name another entity? So pitch is an entity.
Booking.
Booking is another entity. There's one more. Someone shouted out. Pitch fee, yeah. Matt, can you give me an attribute of the booking entity?
Booking entity, week number.
Week number, yeah. Daniel, can you give me another? Customer number, yeah. Jeevan, can you give me the primary key of the booking entity?
Booking reference.
Yeah, booking reference. Good stuff. So booking reference is the primary key because it uniquely identifies every one of these rows. And pitch number is the primary key in pitch, and pitch type rather is the primary key in pitch fee. You see? 3 different tables, 3 different primary keys. Everybody's happy. This diagram down here, the entity relationship diagram, I would strongly recommend that somehow you draw one of these as part of your design for your A-level project. It may be that your program isn't data heavy. Nevertheless, the examiners insist you learn SQL as part of your A-level, and given this is your A-level coursework, if you can show, I learned this on A-level and it was really useful, see? Then they like that. It makes them feel nice. So if you can draw an entity relationship diagram in your design, it will be worth a mark.
Examiners have feelings.
Say again?
There are no examiners have feelings.
They don't really have feelings, they just sort of have occasional chemical imbalances, I think.
Nicely put.
So, if you can draw an entity relationship diagram, then that would be really good. It would be good if you can draw an entity relationship diagram, put it in your projects. Normally, I would sort of teach databases at the end because I like to sort of build up. So we start with like the low-level stuff and CPUs, and then programming languages, and then other things. But I'm teaching this now because I believe you're doing your analysis at the moment in your project. So this would be a good time to learn how to draw entity relationship diagrams. So in your next lesson with Kate, draw one. So we have, there's 4 entities here, but I locked customer off because it wasn't really necessary for this example. So we've got these 3 different entities. How do entities relate? Remember, so the whole point of relational database, we've basically got 3 separate tables here. They're all part of the same database. How are they related? How do you relate entities? Do you remember, Lee?
Links.
Yes, we have links between the tables. I think there were 2 things I wrote down for one of those. I did talk about the links just now. Did anyone write that down when I had the mark scheme on the board? For primary key. I'm just giving it away. Remember on my previous slide a few moments ago, the whole point of primary keys, they're unique identifiers. They're also used to relate the entities. And this is how they're used to relate the entities. So we have these 3 different entities. And as you can see, we have, so in booking, we have booking reference, we have pitch number, we have week number, we have customer number. Pitch number here in booking is the same as pitch number here in pitch. You see? So, I don't know, someone calls up and makes a booking, and the booking reference 318. Someone calls up and says, I want pitch number 42, I want it in week number 22, and I want, this is my customer number. So they've booked pitch number 42. How do you find out about pitch number 42? Well, you take the what's called the foreign key here, and you use it to find the primary key in a different table. So 42 over here means 42 over here. Is this going to work? It does. Splendid. There. So you look at your booking reference, you find pitch number, you want to find out more about the pitch they booked, so you use that, and there's your link. You use the pitch number value from the booking entity to find the primary key in pitch. So this here is known as a foreign key. It's another magic word that you do need to know. It's well worth writing down. The foreign key in an entity, a foreign key is a primary key of one entity when it appears in another entity. A foreign key is the primary key of one entity, such as pitch number in pitch, when it appears in another entity, such as pitch number in booking. It's the same attribute appearing in two different tables. In one table, it's a primary key. In pitch, it's the primary key. In booking, it's the foreign key. Or in exam speak, a foreign key is the primary key of one entity when it appears in another entity. So, Peter, can you tell me, so I've given you one example of a foreign key. So pitch number in booking is a foreign key because it's a primary key that appears in pitch. Can you give me another example of a foreign key? Pitch type, yes. Pitch type in pitch is a foreign key. Pitch type is a primary key of one entity when it appears in another entity. So here, it's the foreign key, and over here, it's the primary key. You see? Foreign key is the primary key of one entity when it appears in another entity. That's what it means, and they are used to relate entities. Foreign keys are used to relate entities. If we didn't have this foreign key here, there'd be no relationship between these tables. You see? There's a fair few marks on foreign key. In fact, there are quite a few if you fully understand them, and the question is right. So you get a mark for saying it's the primary key of one entity when it appears in another entity. You get another mark for saying the example, so it's a primary key here and a foreign key here. And you get a further mark, or possibly often even 2 marks, for being able to draw the entity relationship diagram that goes with it. So the entity relationship diagram, this obviously you can see is going to get quite complicated. So we have these entities, and we have, and these are primary keys, and then we have these foreign keys. And already you can see that my diagram is a little bit incomprehensible, even if I rub out the stuff in green that I wrote. It's still pretty complicated. So that's why entity relationship diagrams exist, to try and simplify some of this stuff. So pitch to booking is what's called a one-to-many relationship, because it's one here to many over here. Pitch to booking is a one-to-many relationship. Because, if you think about it, here we have pitch, and pitch number. Each pitch appears in pitch only once. But it will appear the same pitch will appear many times in booking. Does that make sense? So each pitch will appear once in pitch and many times in booking. So it's a one-to-many relationship. This is the kind of thing that seems really simple, but whenever you try and work it out, it's always complicated. Certainly whenever I try and work it out, it's always complicated. So similarly, we have a relationship between pitch and pitch phi. Which way round is it? I'll pick on one of you at random in a minute. Which way round is it? The relationship between pitch and pitch phi. Just look at it for a moment, see if you can work it out. Is it a one-to-many, many-to-one, many-to-many, or just one-to-one? All those relationships are possible. What do you reckon, Dave?
It's one to many from pitch phi to pitch.
One to many from pitch phi to pitch. Who agrees with Dave? Most of you. He's right. Pitch fee. So each pitch type appears in pitch fee only once, but appears in pitch rather many times. So each pitch appears in pitch fee once and appears in pitch several times. You see? One to many. One to many. You can't see it, but does anyone want to, and I haven't actually got the, does anyone want to hazard a guess at the relationship between customer and booking? Go on, James.
Would it be from booking to customer many to one? Because a customer could have several bookings.
Yes, you're absolutely right, and that's exactly how it works. It's brilliant. Good. One customer will make many bookings. Sometimes it is as simple as that, if you can think logically about it. Sometimes it can get very complicated, and it's difficult to work out which way around it goes, which is why maybe it's good to do some more complicated examples, where a pitch type is a sort of, if a pitch fee is a strange concept, and pitch is a strange concept, and pitch type can all be a bit odd. But yeah, sometimes it is as simple as going, one customer will make many bookings. So the same customer number will appear many times in this foreign key. Cool. Or to put it another way, the side that has the primary key, so customer has the primary key, booking has the foreign key. Pitch has the primary key, booking has the foreign key. Pitch fee has the primary key, pitch has the foreign key. So the primary key, the primary key is on the one end, the foreign key is on the many end. So, that's probably enough of my blathering for a moment. We've got a little exercise for you. I'd like you to design a database. I'm turning you all into database engineers. First, I want you to define these three entities. And then I want you to tell me what the primary and foreign keys are. You do it in Excel, do it on paper. Not that bothered about how you do it, but that's what I want you to try and do. Feel free to discuss it with each other, though to be honest, to start with, you shouldn't need to. So, yeah, if you can do that, have a go.